Hello students, we have studied the basic information of modern periodic table in standard 11. In the modern periodic table, elements are arranged on the basis of their electronic configurations. We will just revise the definition of element. An element is a substance which cannot be further divided into simpler form either by any physical or chemical method. Now, see here, depending upon the type of subshell in which the last electron of an atom enters, elements are classified into 4 blocks. These 4 blocks are S block elements, P block elements, D block elements and A block elements. So, in 12th standard chapter, transition and inner transition elements, we are going to study in details D block and A block elements. First, we will see the definition of D block elements. D block elements, these are the elements in which the last electron enters to the D subshell of penultimate shell. First, we will see what is meant by penultimate shell. Penultimate shell is a shell which is present inner to the outermost shell or valency shell. एलिमेंटच्या ॲटममध्ये सर्वात बाहेरची जी शेल आहे तिला आउटरमोस्ट शेल किंवा व्हॅलेन्सी शेल असं म्हटलं जातं आणि त्या शेलच्या आतली जी शेल आहे ती असते पेनॉल्टिमेट शेल. सो डी ब्लॉक एलिमेंट्स, दीज आर द एलिमेंट्स इन विच द लास्ट इलेक्ट्रॉन एंटर्स टू द डी ऑर्बिटल ऑफ penultimate shell. Okay, now the position of D block elements in modern periodic table. In modern periodic table, D block elements, they are placed between S block and P block elements. Between S and P block elements, these D block elements, they are placed between the group 3 to 12 and within the periods 4th, 5th, 6th and 7th. So, this is the position of D block elements in modern periodic table. Then, these D block elements, they are again called as transition elements. Transition elements are those elements which have incompletely or partially filled D subshell in their ground state as well as any one of their common oxidation state. म्हणजेच ट्रान्झिशन एलिमेंट्समध्ये डी सबशेल ही इनकम्प्लिटली किंवा पार्शली फिल्ड असते. डी सबशेलची कॅपॅसिटी मॅक्झिमम 10 इलेक्ट्रॉन्स फिलअप करण्याची असते. ज्या एलिमेंट्सच्या ॲटममध्ये डी सबशेलमध्ये इलेक्ट्रॉनची संख्या ही D1 to D9 असेल ते सर्व एलिमेंट्स हे ट्रान्झिशन एलिमेंट्स म्हणून कन्सिडर केले जातात. आता ट्रान्झिशन एलिमेंटच्या या डेफिनेशनप्रमाणे जर तुम्ही पाहिलं तर 12 ग्रुपमधले जे झिंक, कॅडमियम, मर्क्युरी हे जे एलिमेंट्स आहेत ते सर्व एलिमेंट्स हे ट्रान्झिशन एलिमेंट्स नाहीत. कारण तुम्ही जर त्यांचं इलेक्ट्रॉनिक कॉन्फिगरेशन डिटेलमध्ये बघितलं तर ह्या सर्व शेल्समध्ये डी सबशेल ही कम्प्लिटली फिलअप आहे, म्हणजे 10 इलेक्ट्रॉन्सनी पूर्णपणे भरलेली आहे आणि म्हणूनच हे जे 3 एलिमेंट्स आहेत झिंक, कॅडमियम, मर्क्युरी ते ट्रान्झिशन एलिमेंट्स म्हणून कन्सिडर केले जात नाहीत. दे आर ऑल्सो कॉल्ड ॲज सीडो ट्रान्झिशन एलिमेंट्स. ओके, then next, see here, these transition elements, they are classified into 4 series. So, we will see the classification of transition elements. Transition elements, they are classified into total 4 series. These 4 series are first transition series, second transition series, third transition series, and last one, fourth transition series. First, we will see first transition series. First transition series, this series, it starts with scandium, which having atomic number 21, and it ends with zinc, which having atomic number 30. Again, this first transition series, it is also called as 3D series, because in all these elements, the fourth energy level is outermost. But as these are the d block elements, the last electron enters to the d subshell of third energy level. Therefore, this first transition series, it is also called as 3D series. Then next, second transition series. The second transition series, it starts with yttrium, which having atomic number 39, and it ends with cadmium, which having atomic number 48. Second transition series, it is also called as 4D series, because in all these elements, fifth energy level is outermost, but the last electron enters to the d subshell of fourth energy level. Therefore, it is called as 4D series. The next, third transition series. This third transition series, it starts with lanthanum, which having atomic number 57, and it ends with mercury, which having atomic number 80. Now see here, this third transition series, the first element is lanthanum, which having atomic number 57. After lanthanum, the next element is hafnium, which having atomic number 72. Then where are the elements which having atomic number 58 up to atomic number 71? These elements which having the atomic numbers between 58 to 71, they are placed separately at the bottom of the periodic table within a block elements. So, these elements which having atomic number 58 to 71, they are not the A block elements, they are not the D block elements, but they are the A block elements. Okay. Then next, fourth transition series. This fourth transition series, it starts with actinium, which having atomic number 89, and it ends with copernatium, which having atomic number 112. This fourth transition series, it is also called as 6D series, because in all these elements, seventh energy level is outermost, but the last electron enters to the d subshell of sixth energy level. Therefore, this fourth transition series, it is also called as 6D series. So, this is the classification of transition elements. Then the next point is how to write the electronic configuration of transition elements. Before that, we will just revise the sequence of atomic orbitals according to Apovo principle. According to Apovo principle, the increasing order of energy of the orbital is as electrons will first enter to the 1s orbital, then next 2s, then next 2p, up to so on. We will just revise the maximum capacity of each subshell. S subshell, its maximum capacity is of 2 electrons. P subshell, maximum capacity of 6 electrons. D subshell, maximum capacity of 10 electrons, and F subshell, the maximum capacity is of 14 electrons. Now, we are going to write the electronic configuration of first element scandium. Scandium, it having atomic number 21. That means we have to fill up the total 21 electrons in subshells. According to sequence of above principle, the filling of orbitals is as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and the last electron it enters to the 3d subshell, and the last subshell electronic configuration becomes 3d1. So this is the electronic configuration of scandium. But here it is not necessary to write the whole electronic configuration every time. प्रत्येक वेळी हे सर्वच्या सर्व इलेक्ट्रॉनिक कॉन्फिगरेशन लिहिलं जात नाही, त्याच्याऐवजी हेच इलेक्ट्रॉनिक कॉन्फिगरेशन कंडेन्स्ड फॉर्ममध्ये लिहिलं जातं. While writing the condensed electronic configuration, the symbol of nearest inert gas is used. The symbol of nearest inert gas, it is written within the square bracket, and only the outermost electronic configuration is written outside the square bracket. So, while writing the electronic of scandium, the symbol of nearest inert gas argon is used. Argon, it is the element which having atomic number 18. According to above principle, its electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6. So, while writing the electronic configuration of scandium, the use of this symbol of argon is made. The symbol of argon is written within the square bracket. See here, the symbol of argon is written here. Up to this 18 electrons are filled up, and the remaining electrons, 3 electrons, they are written as 4s2, 3d1. So the condensed electronic configuration of scandium becomes argon 4s2, 3d1. आता हा जो सिक्वेन्स आहे तो अफवा प्रिन्सिपल प्रमाणे एनर्जीच्या ऑर्बिटलच्या एनर्जीच्या चढत्या क्रमाने आहे. हेच इलेक्ट्रॉनिक कॉन्फिगरेशन याही प्रकारे लिहिले जातं अर्गॉन 3d1 4s2. आता या ठिकाणी मात्र हे इलेक्ट्रॉनिक कॉन्फिगरेशन लिहित असताना एनर्जी लेवलच्या इन्क्रीजिंग ऑर्डरमध्ये लिहिलं गेलेलं आहे. हे दोन्ही इलेक्ट्रॉनिक कॉन्फिगरेशन्स बरोबर आहेत. ओके. Then next element is titanium, which having atomic number 22. According to condensed electronic configuration, its electronic configuration becomes argon 3d2 4s2. आता याच प्रकारे राहिलेल्या सर्व पहिल्या ट्रान्झिशन सिरीजमधल्या एलिमेंटचे इलेक्ट्रॉनिक कॉन्फिगरेशन या टॅब्लो फॉर्ममध्ये दिलेलं आहे. जर तुम्ही हे टेबल केअरफुली पाहिलं तर तुम्हाला दोन इलेक्ट्रॉनिक कॉन्फिगरेशन्स ही रेड कलरनी मार्क केलेली दिसत आहेत. पहिलं जे इलेक्ट्रॉनिक कॉन्फिगरेशन आहे ते आहे क्रोमियमचं आणि दुसरं जे इलेक्ट्रॉनिक कॉन्फिगरेशन आहे ते आहे कॉपरचं. आता हेच इलेक्ट्रॉनिक कॉन्फिगरेशन जर तुम्ही डिटेलमध्ये पाहिलं तर ते या प्रकारे आहे बघा. क्रोमियम एक्सपेक्टेड इलेक्ट्रॉनिक कॉन्फिगरेशन इज argon 3d4 4s2, but the observed electronic configuration is argon 3d5 4s1. आता ह्या दोन्ही इलेक्ट्रॉनिक कॉन्फिगरेशनमध्ये फरक का आहे तर ते आपल्याला आपण 11th स्टँडर्डमध्ये स्टडी केलेल्या एक्स्ट्रा स्टॅबिलिटीच्या रूलनं एक्सप्लेन करता येईल. व्हॉट इज दॅट एक्स्ट्रा स्टॅबिलिटी रूल? Those atoms in which the subshells of outermost shell are exactly half filled or completely filled, that atoms possess extra stability. So, in case of chromium, to achieve 5 electrons in 3D subshell, 1 electron from 4s it get promoted to 3D subshell, and the observed electronic configuration becomes argon 3D 5 4s 1. By achieving 5 electrons in 3D subshell, chromium achieves the extra stability. Similar to that of in copper, its expected electronic configuration is argon 3D 9 4s 2. But the observed electronic configuration is argon 3D 10 4s 1. Again here, to achieve the 10 electrons in 3D subshell, 1 electron from 4s it gets shifted to 3D, and the observed electronic configuration of copper becomes argon 3D 10 4s 1. So, by achieving 10 electrons in 3D subshell, copper achieves the extra stability. So, if you observe all the elements electronic configuration, you will find that the 3D subshell, the range of 3D subshell is from 1 to 10, and the 4s subshell, its range is from 1 to 2. So, from all these observed electronic configuration, the general electronic configuration of 3D shell, 3D series, it becomes argon 3D 1 to 10 4s 1 to 2. Similar to that of the 4D series, its general electronic configuration is krypton 4D 1 to 10 5s 0 to 2. Here, in case of 4D series, palladium, it possesses empty 5s subshell. So, here the general electronic configuration of 4D series, it's become krypton 4D 1 to 10 5s 0 to 2. Then 5D series, the general electronic configuration is xenon 5D 1 to 10 6s 1 to 2. Then next 6D series, the general electronic configuration is radon 6D 1 to 10 7s 1 to 2. आणि हे सर्व इलेक्ट्रॉनिक कॉन्फिगरेशनवरून जर आपण डी ब्लॉक इलेमेंट्सचं किंवा ट्रान्झिशन इलेमेंटचं इन जनरल इलेक्ट्रॉनिक कॉन्फिगरेशन लिहायला गेलो तर आपल्या असं लक्षात येतं की डी सबशेलमधली इलेक्ट्रॉनची रेंज ही 1 to 10 आहे, तर एस सबशेलमधली इलेक्ट्रॉनची रेंज ही 1 to 2 आहे. आणि या सर्व इलेक्ट्रॉनिक कॉन्फिगरेशन्सवरून आपल्याला इन जनरल इलेक्ट्रॉनिक कॉन्फिगरेशन ट्रान्झिशन इलेमेंट्सचं या प्रकारे लिहिता येईल. The internal electronic configuration of transition elements is n-1d 1 to 10 ns 1 to 2. Thank you.